Hello my dear friends, welcome back to our channel. So this is the second video related to analog sensors. In our first video we have seen some analog sensors like temperature measurement and all. Now we will see other few type of sensors. So one we have here ultrasonic sensor and the second one is the DHT11. Let us get into the topic. First one is ultrasonic sensor. So before get into the core topic, so let us have a revision about the basic formula. So distance equals to speed into time. So everybody might be knowing this formula, so there is nothing new in this. Just to keep refresh your basic formulas. Now, so this is a pictorial representation of the ultrasonic sensor. So this is how it looks like. It has 4 terminals: VCC, trigger pin, echo pin, and ground. So these are few specifications. So resolution up to 0.3 centimeter, and it can measure range from 2 centimeter to 450 centimeter. Okay. So how this ultrasonic sensor is going to function? So in the ultrasonic sensor, basically it has two transducers. One transducer acts as a transmitter which transmits ultrasonic signal with a 40 kilohertz frequency, and this signal is transmitted in the air medium, and within the range, if an object is placed, this signal hit the object and it reflects back to the sensor itself. When the signal reflects back, the second transducer in the sensor module receives it, and this received signal is given back to the controller. Okay, so triggering, that means starting or giving the pulse output, is controlled from the microcontroller when the signal has to be transmitted and when it is received, how to take to the controller. So both will be programmed in the microcontroller. So once we give the trigger pulse, it will emit the pulse here at 40 kilohertz frequency, and it goes within the range. If an object is there, it hits the object and it reflects back to the receiver pin. And once it is receiving in the receiver pin, then it is going through the echo pin to the microcontroller. Okay, so if, for example, if the object is placed 20 centimeter away from the sensor and the speed of the sound is 340 minutes per second, meter per second, yeah. So or you can convert into centimeter per microsecond, 0.034 centimeter per microseconds. So when we know the distance and the speed, so we have just seen here, we know that the distance and speed, so we can calculate the time. So here time is equals to distance by speed. So we know the distance and we know the speed. 20 divided by 0.034 centimeter per microseconds, it comes as a 588 microseconds. So we can calculate the time taken to reach the object, and then it is only for time taken to reach the object. Okay, and it will reflect back. So it will reflect back, so the time will be for sending and receiving, it has to be multiplied by 2. Or on the other end, usually in the microcontroller we get the time period here. So when we get the time period, then we know the speed and we know the time. So again we can go back to this. When we know the time and we know the speed, the distance can be calculated like this. So time taken can be taken in the program, and speed we know that. So multiplying these two will give the distance. Very simple. And once we multiply this, the time taken is for going from the sensor to the object, and from object again it reflect back to the sensor. So two times. Okay, so traveling towards and traveling backwards. So we have to divide this value by 2 so that you get an exact distance. So let us see. So this is a wiring. So we have a Arduino, and VCC is connected with the 5 volt, and ground is connected to ground pin, and trigger pin and echo pin we can connect in any digital pins, and we can write the code. So here in the code you can see I have declared two variables. One is a duration, so that means how much time it takes to to and fro travel, the time taken to reach from sensor to object and again from object to sensor. So this is a duration. Using, when we get the duration, then we can calculate the distance. Okay, so these two as a variable, and the trigger pin is connected to 13th pin of Arduino, and echo pin is connected to 12th pin of Arduino. So this can be any pins like 7, 6, 4, 5, like that, any two pins we can use it. And in the setup we are just defining that trigger pin is acting as an output. So that means it has to send the output signal, okay, from the Arduino. The signal will be sent to the ultrasonic sensor, so that the ultrasonic sensor can emit the pulses. Okay, and echo pin has to receive the input from the sensor to the Arduino, so it is acting as an input pin. So we are just declaring that. And so this serial dot begin 9600 is nothing but initializing the serial port communication with the baud rate or a speed of 9600 bits per second. Right. Now, in the loop, what we do, first we write the digital write trigger pin low for 2 microseconds. Okay, we are just making the trigger pin low for 2 microseconds, and then we write a digital write trigger pin high for 10 microseconds. So this means when we give the trigger pin high for 10 microseconds, that means the ultrasonic sensor is going to produce the signal, ultrasonic signal with the 40 kilohertz frequency, and it is going to be transmitted. After 10 microseconds, then again trigger pin will go to the 0. So that means it will stop generating the signal. Once we transmitted the signal, so we have to wait for the reflected back signal. So that is received using this echo pin. Okay, pulse in echo pin high. Okay, so when the echo pin goes to high, okay, and high to high transition, how much time it is taking, so that transition time will be calculated in the duration. Okay, so the pulsing pin will see the two high transitions, 0 to 1 or 1 to 0, that high or low. You can mention here, if you want to low transition you can write low here, or if you want to see the high transition, that is 0 to 1 transition, you can give high. So this pulsing function is going to see when the echo pin is going to change to 0 to high. So that time period it is going to take it in the duration. Okay, so once we get the duration, so that means the signal is transmitted and it is received back, so that is a duration. Once we get the duration, that we will multiply with the speed of a air, so sound 0.034. So this is, we have seen little earlier slide, 0.034 is the speed of the sound. So once we get these two, so the distance is, as I told you, the forward motion as well as the return time is distance is there, so we have to divide it by 2 to get the exact distance. Okay, so then we will display it in the serial monitor. So if you want to do some work using this, we can do that work. Say for example, you want to avoid any object like a robot. Okay, you are having a robot, line following robot, or any robot. Okay, so you want to avoid obstacles. Okay, so that kind of applications areas we can use this. And when it is reaching to any obstacle, it will say that there is obstacle, so turn back or turn right. So that kind of a code we can give. So I have not shown that for easy understanding here. So I just uh, put the basic of this one, how to get the distance by getting this distance. Then after that, as per your application, you can use this distance to do any work. Okay, so let us see this in the Arduino. I have connected it here in the Tinkercad. We can see that one simulation. Okay, I have a Tinkercad simulation here. So the same code I have copied it here. Okay, I'll just put the serial monitor here. So it shows now 88 centimeter. So here is the sensor. The object is placed here. So you can move the object. So respectively the distance is getting changed. So you can move upward or downward, wherever it is. So accordingly the distance is getting measured, and it is also displayed here. Suppose if it is the object is goes out of the range, then it gives some garbage value. Okay, so it will not show any correct values. So even here you can see the same number. Okay, it is a default values, but when it is coming into the range, then you can get the actual reading here. Okay, actually it is in the simulation they show like almost 1.2 inch, something like that, but in practical case we can measure even closer values. And the distance here they show up to here, yeah, up to almost 310 centimeters. We have seen also in the presentation here, it is also the spec is given up to 450 centimeter, 2 centimeter to 450 centimeter it can measure. In the simulation they have given until 310 centimeter. Okay, so this is about the ultrasonic sensor simulation, and it's very simple. I hope you can easily understand this. Okay, I will put this code also in the description box. You can do this one. This is a Tinkercad one, Tinkercad. So in the previous simulations also I have used the same thing. Okay, so it is a free software in the online. You can just log in with your credential. You can create one login and you can log in. Then it is all free. You can use all the components, all basic components. All components are available here. Most of the analog sensors and the digital sensors, motors, all are available here. You can do as a beginner. You can learn using this Tinkercad. Okay, now let us go back to the topic. So that's about the ultrasonic sensor. Now let us go to the second one, DHT11. So now in the previous sensor we measured the distance. In this DHT11 we can measure a temperature and humidity, relative humidity. So the DHT11 measures the relative humidity. So we know what is relative humidity. So the relative humidity is nothing but the water vapor in the air versus the saturation point of the water vapor in the air. Okay, so the saturation point is nothing but the water vapor start condense and accumulate on the surface forming dew. So that is called the saturation point. So this sensor is used to measure the relative humidity. So at 100% relative humidity, condensation start occurring, and at 0% relative humidity, the air is completely dry. Okay, so this is for just for information. So this sensor has two basic part inside. So that is, one is for measuring the relative humidity, and the other sensing part is for measuring the temperature. So first one we will see what is about the relative humidity measurement sensing unit. So this sensing unit has two electrodes and one polymeric membrane. So this polymeric membrane is the one which can observe the moisture in the air or humidity in the air. So when it is observing the moisture in the air, the ions in this polymeric membrane get increases. When the ions are getting increased, what happens? The conductivity will increase. So in vice versa case, when the dry air it comes into the picture, so when the polymeric membrane is getting dried up, the conductivity will get decreased. Or if the moisture content is more, then what happens? Then automatically the conductivity will get increased. So by measuring the difference in this resistance, so we can calibrate that one to the moisture content in the air. So this is the basic principle of this DHT11 humidity measurement. Okay, so now it has one more component for temperature measurement. So it is nothing but a thermistor. Okay, so thermistor can be of two type: NTC temperature, and PTC, positive temperature coefficient sensors. So this one in the DHT11 we have NTC type of temperature sensor. So NTC means negative temperature coefficient. So that means the relationship between the temperature and the resistance is inversely proportional. So when the temperature is increasing, the resistance will decrease, or vice versa case. Okay, so that is nothing but a negative temperature coefficient sensors. Okay, this thermal resistor, so based upon the temperature, the resistance will change. So that is nothing but a thermistor, thermal resistors. So if you see this graph for the NTC, you can see the resistance is getting decreased when the temperature is increasing. You can see from 1 degree Celsius to 59 degrees Celsius, what happens? So the resistance is dipping from 5 lakhs, almost 5 lakhs ohms to almost it is coming to no, in terms of 100 ohms or 200 ohms. So this variation in temperature resistance with respect to temperature can be used to measure the resistance temperature. Okay, so when we are we can calibrate this much temperature equals to this much resistance. This therefore, if it is reaching to 4 lakh ohms, then it is a 5 degrees Celsius. Like that we can plot a graph. Okay, so this is about the temperature measurement. But actually in the DHT11 it will give you the exact values. These calibrations and everything will be done inside. So it will give you the exact value. It will not show any resistance value, but it will directly show you the temperature value. So this is what I was discussing about. So the connection wise, if you see, actually there are two different configurations available: 3-pin configuration and 4-pin configuration. But in both configuration, DHT11 uses only 3 pins. So one is a signal pin, so that is output pin, and remaining 2 is for positive supply and a ground. Okay, 3 pins only is available in this, and the code is very simple, as we can see on the screen. We have a library file. Until now we have not seen any library file for any of the program, but here in this code we have a library file. So these library files can be downloaded from the website. Okay, so when you want to do the wiring for this, so we can download the library file, include dht.h. so you just type a dht11 library files on the Google, so you will get the library files. Okay, and this library file you have to add in the Arduino IDE. So how to add that in the library files to the Arduino IDE? So you can go to the sketch. So in the sketch you can see include library. So in the include library, go to the add zip library. So once you downloaded the zip file, so you can give this add zip library. So in from the download you can copy that file. Okay, or just add that file. So once you add it, so related to that whatever is header file is available, it will detect. You can see here dht lib. So this is the header file which I have added earlier. Okay, so when we add this DHT lib. So that means the functionality, whatever they have written inside this header file, so those functions can be utilized in the program. So here in the program you can see include dht.h. So this is a, that means whatever the functions they have written inside this library, I am going to use it. So the functions also, dht.read11 is a function which is defined inside this library. It is, I have not defined anywhere here, it is defined inside this library file. Okay, and you can see dh.humidity, dht.temperature, these all things I have not defined anything here, so these are all defined inside this library file. Okay, so I am just utilizing the functions, and I am taking the values and putting the values in the serial monitor here. Okay, so actually it is so simple, and the wiring also can be done physically here. It is not a very difficult one. So as I told you, only 3 pins are there. It is very easy to take the data. So once you upload the program, so you get the program and compile it and then upload it. Once you upload the program, you can see the readings in the serial monitor. So I will just upload this one. So it is uploading the program to the Arduino, and then now I can give the serial monitor here. So in the serial monitor it shows the temperature and humidity. So here now the temperature is almost 24 degrees and humidity is almost 49%. Okay, so this is the temperature and humidity. So this sensor can be used for like a weather station, like what is the humidity we have, what is the temperature we have. Okay, it's a very simple sensor, but it can give two different variables there. And if you include a pressure sensor to this, it also can give the atmospheric pressure. So all these things together we can have a weather station kind of application. And if you want to control the temperature in that process or humidity in the process, you can use this data and do the controlling process. Okay, so it's very simple. So these are the results which I have shown now. Okay, and one more sensor we can see, so that is interfacing PIR sensor. So PIR sensor is nothing but a pyroelectric sensor or a passive infrared sensor. Yeah, okay, so these passive infrared sensors are used to detect motion. So we have seen the sensor which is used to measure distance. Now we are seeing the sensor which can detect the motion. So if any movement is there, then it will give the output. If when there is no movement, then it will not give any output. So how this sensor is going to work is, the basic principle is any object which is having the temperature above absolute zero will emit heat radiation in with respect to infrared radiations. So these infrared radiations can be measured using the sensors. So these infrared variations signals, if is there any variations in that, then it will say that the object is moving, the motion. Okay, if there is no movement, then there is no variations. That means it will say that there is no movement, then it will be in a zero position. Okay, so this actually gives the output in digital format 0 or 1, so whether the object is moving or not moving. Okay, like that. It's very, again, it's very simple sensor. We have 3 pins only in this sensor as well. So we have supply, ground, and we have one terminal for the signal or output signal. So here we are declaring the pin which we are connecting as a input in this one. So sensor, so 13th pin I have connected the sensor, and we are declaring it as the input pin. So that means we are going to receive the signal from the sensor. We are not going to send any signal to it. We are just going to receive it. So we are declaring as a input pin, and serial monitor to see the output in serial communication. So we are put this serial monitor serial.begin 9600 baud rate. Okay, so whatever the data I get it here in the digital read sensor is 13th pin. So from the 13th pin, whatever I am reading, I am storing in the sensor value. This is a memory location, and this value whatever is there here, it is displayed in the serial port. So it will show either 0 or 1 with respect to the object availability on the vicinity. So now we will see the simulation for this type of sensor as well. Okay, so the code is the same which I have shown there. I just copied it here. I just put the serial monitor here, and then I will start the simulation. Okay, so here is the object. It is in the range, but it is not moving. The object is not moving, so it is showing 0. When the object is moving, you can see the sensor become a red color here, so that means the signal is detected, and it shows only a short time period. You can see here it is there and goes off. Okay, so in this sensor we have two potentiometers at the back side. One is to adjust the sensitivity of this sensor, and the another one is to adjust the time, how much time it should give the output. Say now you can see when the object is moving, it is showing 1 for a small period of time. This time period can be adjusted. Okay, how much time you want the signal to be present, that can be adjusted using another potentiometer, and sensitivity also can be adjusted in this type of a sensor. So when we get 1, so that means the object is moving. So this type of sensors can be used in like intruder alert. Okay, so you can place this sensor near where you want to find is there any motion is there, that kind of things. Okay, intruder alert and kind of things we can make using this type of sensor, motion detecting sensor. Okay, so it will not detect any object which does not have any temperature in the this one. Say like for example, you want to move any plastic object or anything like that, it will not detect. So any physical man or any animal, if anything is moving, that has its own temperature in that. So when it is moving, then the radiation can be detected, not any non-living objects like wood, that kind of things. If you are moving near to it, it will not detect. Okay, so it will detect only the object which has some temperature in its body. Okay, so this is about the simulation for this. Okay, so we have a few more sensors, so hope we will see in the next meeting or next video. So we will wind up for today's session. Hope it is clear, and I will also try to put this programs in the description box. If you have any doubts, let me know, I will clarify. Or if you want any topic related to this Arduino, you can let me know. I will also make a video and I will present it for you. Okay, thank you so much for listening. We will see in the next video. Thank you.